So in this problem, I've started with a chart class that can draw charts of some kind. And so when you draw a chart, you might think of like bar charts or pie charts. But the charts that I've had are a little bit different. Those bar charts and pie charts, they would be one-dimensional because you just have a series of values. The ones that we're looking at this exercise, they're two-dimensional, so where you have a series of points with both an x and a y coordinate. So the two charts that we're looking at here are those ones with the dots, and those dots could come in any random order, some cloud of measurements, and we would just draw each of them as a dot, and the statisticians would hope to divine some meaning out of those dots. The other situation that you often have with dots is you have these measurements, and then you want to connect them by lines. So in this situation here, how would you connect them by lines? You would, kind of go like this and say that is the fluctuation of whatever, someone's GPA, the stock prices, the intelligence of the CEO, what do you know? So in the second situation, you will draw the lines, and there's still some basic stuff that's the same, namely one has to collect those dots. So when you look at this chart class here, that's what the superclass does. It collects the dots in an array list of points, and when you add a point, it just adds it to the array list. And when you ask what are all the points that were collected, you get this array list. Now, how do you draw the chart? That's something that the basic chart knows nothing about. So here this method is empty. It would draw exactly nothing. In the chart, in the subclass here, in the dot chart, then what we would do is go through the data and plot each of it as a little circle. So we call the getData method from the superclass, and so that's the beauty of inheritance. You don't have to re-implement that. Someone else, whoever implemented the chart, in this case it was me, gave it to you, and then when you implement the dot chart, you can just call the methods of the superclass, benefit from the job that's being done, and you don't have to worry about that. So we iterate through the data that getData returns, and for each of them we draw a dot. And that's really the end of it. So when we run this, the first one here gets us a somewhat confusing set of dots where you kind of perceive some sine waves. So let's look at the code here to see where this comes from. So the points that we were plotting, the x coordinate was 0 and then went on to 5, 10, 15, 20, and so on up to 300. The y coordinate was, so we took the sine of these numbers. Now, we didn't really pay any attention to whether we're using degrees or radians, so we're actually using radians. So that sine value is going to be kind of all over. Now, the sine value is some number between -1 and 1. By multiplying with 100, you get some number between -100 and 100. And by adding 110 to it, you get something that's between 10 and 210. That way none of the pixels were cut off. And you're going to have to wait until we get to the answer of part C to see what the meaning of this graph really is. Right now, it just kind of looks like, something sine-like, and it's not so clear why it goes back and forth. Also, when you look at the printout here, in the draft, I asked you to implement the toString method, and in the way that was done in the book, that generally the way you implement a toString method is you print the name of the class, and then you print the values of each of the instance variables. So let's have a quick look at that. So over here, I've done it in the fancy way, since that's eventually what you're going to have to learn how to do. If you simply printed the name point, that's fine too for this one. But eventually, because you want to be able to form subclasses of point and still have this come out right, we print the name of the class followed by the value of the x instance variable, followed by the name of the y instance variable. And it's kind of customary to have this style here, where you have the name of the class, then a bracket, then the name of the field, and the value, the name of the next field, and the value. Many weeks ago, you've actually printed out rectangles in this way, and they looked exactly the same way. It said java.awt.rectangle over here, and then x, y, width, and height. And so that's the traditional format that you use in Java.